Let's take a look at another example of how to use the trapezoidal rule to approximate the area under a curve. Here we want to approximate the integral from 0 to 1 of square root of 1 minus x cubed dx. And we want to do that with 5 subdivisions. So let's take a look at the graph of that and what exactly we're trying to do. So here's the curve from 0 to 1 of square root of 1 minus x cubed. And if we want 5 subdivisions, and that would mark the end of each of our trapezoids, and then of course the 5th trapezoid would end at 1. If you think about how the formula for area of a trapezoid goes, we know we need to have a multiplier of 1/2, and then the height of each of these trapezoids is going to be given to us by b minus a over n, where n is the number of subdivisions. So we have 0 minus 1 over 5, which is a 5th, or 0.2, which makes sense because the way I have this broken up, this would be 0.2, 0.4, 0.6, 0.8, and then 1. So the height of each of our trapezoids, if you were to turn your head to the left, is going to be 0.2. So let's go ahead and start setting up our formula. Recall that use of the trapezoidal rule is only an approximation. So therefore you do need your approximately equal to symbol. Use of the squigglies for that is of course acceptable. So as we were saying, we need a multiplier of 1/2 because of the actual formula for area of a trapezoid. The height of each one, as we talked about, is 0.2, or you could use 1/5. Either one, of course, is fine. And then we need to start in with the sums of the bases. So the base of the first trapezoid is going to be given to us by the function value at 0. And then you might recall we have to start doubling the rest of the bases because, for instance, this first trapezoid that ends right here at 0.2, this is the base of the first trapezoid, but the top of the second trapezoid. When we turn to the function value we'll need at 0.4, that also has to get doubled because it's going to serve as the bottom base of the second trapezoid and yet the top base of the third trapezoid. And we continue on in that manner. And then finally, when we get to the end, the function value at 1 is serving only as the base for that final trapezoid, and so it is only needed once. The part that you see here in the square brackets, we will go ahead and do in our graphing calculator so that we do not have to round off until the very end, and then, of course, we'll need to multiply once we have that by 1/2 and 0.2. So let's switch to the graphing calculator and go ahead and do that. You'll want to have your function under y1, and then if you go to your quit screen, we're going to type out that part we had written in the square brackets. So the first thing we need is the function value at 0. So remember you hit vars, then across the top to y vars, into function, and y1. Again, it looks just like your f of x function notation, y1 at 0. Plus, and now we start with having to multiply these bases by 2. So we have 2 times the function value at 0.2. Of course, you could do fractions if you prefer. Plus 2 times, now we need the function value at 0.4. Plus 2 times the function value at 0.6, plus 2 times the function value at 0.8, and finally the function value at the end at 1. Hopefully that's what you get for your answer. Now remember, we still had to multiply by 1/2 from the half that was included as part of the area formula for a trapezoid, and then also the 0.2, the 1/5, that was the height of each trapezoid individually. So in the end, for our answer, we have an approximation of 0.809 for the area under the curve.